Welcome back to Chandrasekhar Research Academy of Business Studies. Today, we're diving into the normal distribution, a cornerstone of statistics and analytics. The normal distribution, often called the bell curve, is widely used to model real-world data. In this session, we'll explore its features and examine real-life examples that show its practical applications. The normal distribution is a continuous probability distribution with the following characteristics. It is symmetrical around the mean. Most data points cluster near the mean, with fewer in the tails. The area under the curve represents the total probability, which equals 1. This distribution is crucial because many natural phenomena, such as test scores, heights, and product measurements, follow this pattern. Let's take a workplace scenario. A company evaluates its employees' performance, and the scores follow a normal distribution. The mean performance score is 75. The standard deviation is 10. Question: what is the probability that an employee scored between 65 and 85? Step 1. Calculate the z-scores. A z-score measures how far a data point is from the mean in terms of standard deviations. For a score of 65, subtract the mean from 65 and divide by the standard deviation. That is, 65 minus 75 divided by 10 equals -1. For a score of 85, subtract the mean from 85 and divide by the standard deviation. That is, 85 minus 75 divided by 10 equals +1. Now let's consider a manufacturing example. A factory produces machine parts, and the diameters of these parts follow a normal distribution. The mean diameter is 50 millimeters. The standard deviation is 2 millimeters. Question: what is the probability that a part's diameter falls between 48 and 52 millimeters? Step 1. Calculate the z-scores. For a diameter of 48, subtract the mean from 48 and divide by the standard deviation. That is, 48 minus 50 divided by 2 equals -1. For a diameter of 52, subtract the mean from 52 and divide by the standard deviation. That is, 52 minus 50 divided by 2 equals +1. Step 2. Use the standard normal table. From the table, the cumulative probability for a z-score of -1 is approximately 0.1587. For a z-score of +1, it is approximately 0.8413. Step 3. Find the probability between the two z-scores by subtracting the smaller cumulative probability from the larger one. That is 0.8413 minus 0.587, which equals 0.6826. Final answer. The probability that a machine part has a diameter between 48 and 52 millimeters is approximately 68.26%. The normal distribution is fundamental for analyzing continuous data and is widely used in fields like workforce management, evaluating employee performance metrics. In conclusion, the normal distribution is a versatile tool that helps us interpret data trends and make decisions based on probabilities. By understanding this distribution, you can unlock insights in business, analytics, and beyond. Thank you for watching. Don't forget to like, share, and subscribe to Chandrasekhar Research Academy of Business Studies for more engaging lessons on probability, statistics, and analytics. See you next time.